why don't we get started today? Actually, got a little lower attendance because of this short week, but we have a little bit less than I expected today. But so thank you for coming. There, I am recording this. Since our coming day, we are going to be doing the activity that everyone's required to do this week. So my goal is that by the end of class day, you are done with this course for the week, and so you can actually don't have to do anything over Thanksgiving break for this, assuming you're in class. If you're not in class, tough, you have to do all this on your own over Thanksgiving break here. So unit 13 is, again, because it's here, we're kind of a short thing, and we're not necessarily covering new stuff, new material. We're just looking at how we generally break problems down into parts and do them there. There is no assignment this week, but there is a discussion post you have to do, and you have to do it by Sunday night as normal. And you also have to post one alternative to someone else's posting today. And my goal in class day is that students here will maybe just do this right now in class. I'm going to give you a little background. So again, while I'm talking about this, you might want to start thinking about what you want to do. What you have to do is there are these practice problems. There are a whole slew of different past problems, the different tabs here, and you have to pick one of them, pick one of these practice problems, and decompose it into steps and stuff. And so what you'll have to post is a project plan, a list of steps or methods needed, some pseudocode for a couple of the key steps, and an implementation plan, what order you would do the steps and why, and then break some of the, maybe if you have a complicated step, break it down into some smaller steps here. And that's what you will post the discussion. And I'll spend some time talking about this in the learning materials. So in the learning materials, I'm going to go over the hollow plus sign. This was a hard option when we were learning for loops. Idea is that you'd enter a number in and you'd print a plus sign depending on the size of that number here. So it's just, you entered a multiple of 3 here, and if you entered 3, you entered the simple plus sign with stars. If you did 6, the next multiple, you did this plus sign. 9 would be this plus sign. 12 or 15 would be this plus sign here. So we're going to break that down into steps here. So Chris goes through that here, but we're just going to work through. So, I mean, let's say you wanted to print, and I'm just going to start with one of these middle ones. Often with seeds with different sizes, I find it useful to look at a middle example rather than a really small example here. So what does a middle example look like? I see some rows, we're going to print off each row. Some rows are the same. The top and the bottom row are the same. These rows here and here are the same. All 4 of those are the same. This row and this row are the same. And then we have this row. And then again, even here, we'll see some of these are duplicated more often. So we can see we have some duplicate rows. So, and again, there are different sizes here. It's here. So I would say I would break this up into printing off this top and bottom row. They're both the same. If we had a method for that, that would be fine. And then I would call, what do you call this? Like the across the upper arm and the lower arm, maybe here we'd print off the parts of that. And then we print out, we have to do this and this value. So these are, like the middle cross and then the space in between the middle cross. So again, and Chris goes through this and says, print off the first row of the plus sign, print off the middle rows of the top arm, the top row of the middle arm, the middle rows of the middle area, the bottom rows of the middle arm. Now he doesn't note right now that this and this are the same. I would maybe be noting that in my design right away that some of these are, and same with this, the bottom row of the bottom arm is the same as the first row of the plus sign. So, methods here, and now he begins to do that. So we need a main method. We need to get the user's input. I would actually think that might be part of the main method here because the input seems pretty simple. How many sizes you want and read that in. So I'd actually think of that as the main, but he has it in a set. And again, there's never one right way to break up a problem into parts, but you can decide how you want to do this here. And if I were to do this, I would have put this, the input right in the main. Print top and bottom row. So again, now he's realizing that top and bottom row are the same. Middle rows of the top and bottom arm. And then print the top and bottom middle rows and then the middle area. So again, he's got it broken up into this, and this are his 4 routines, and they all repeat for this. So that's what we want to do, is to try to break a problem up into parts. So why don't you do that? So go to a practice problem here, read through the practice problem here, and try to break it up into problem parts. We call this, or one other way we'll talk about this is problem decomposition. Here, where we're going to take the problem and break it up into parts here. So pick one of the problems here. Like here's the Pokemon problem, and how would you break that up into parts? And you don't have to do the Pokemon problem. You can do any of the tabs here. So read through it, decide on how the steps are, what data you might be storing, how you're going to read in that data, what the different parts of it are. Okay, so I'll let you work on that, and then I'll come back here and we'll talk a little bit about the next step of it. So pick a practice problem and decompose it into steps. So sometimes you'll have to, envision what this program is going to look like to break it up into parts. So like in the Pokemon one, it says you want to store a list of Pokemon. The program should store the names and types of each Pokemon. So then you're thinking, well, how do I want to do this? I'm going to use I need a bunch of names and a bunch of types. I could use an array. I could use an array list there. So maybe I'm saying I'm going to use an array list. So again, and then you're thinking, well, I'm going to have to initialize that array list of names and maybe another array list of types here. Users should be able to add and remove Pokemon from the list. So again, we don't have any graphics here, so we're going to have to ask the user, do you want to add or remove Pokemon from the list? So we need some sort of user interface, some sort of menu that we're going to have to display for this. And then we also have to add and remove, we have to be able to do that. So again, you're going to have to read through. Some of these will have more detailed stuff. So a lot of these, you're going to have to figure out what the problem is, what's your program going to look like, and then break it up into steps here. So let me know if you have any questions on that. Let's talk a little bit about pseudocode and writing pseudocode. So pseudocode is something that should make sense to you, and there's not a set of rules of how to write pseudocode or syntax for it. It is just English that describes code, basically. It is not code, and it's so it's written in English, but it doesn't have to be written in full sentences or anything like that. So you can decide how to do it. So, and again, there's not one specific level. I'll give you a couple hints. So like in this plus sign one, Chris creates his main method and says, welcome the user, get the user's input by calling this get input method. And then he has the pseudocode for that. Print the prompt for the user, int size equals scanner input. This to me almost seems too code-like, but again, Chris, it's not actually Java code, and that's fine. Here it says int and then return size. So that's fine. I tend to write, I think, more English-like pseudocode. I would say things like, now I would combine all this into my main program, but say declare the scanner, prompt the user for the size, read this in the size into an integer variable, and then we're going to divide what he does up here, create the third new variable here, and I give it a name, size D3, by dividing the original size by 3. In this program, you've got to enter a size, a multiple of 3 here. I don't really like how that programs. I would have rather just entered a size 1, 2, 3 and then have the computer multiply, but that's how it's written. Now, why do you write pseudocode? So part of it is to kind of force you to walk through the steps and then to see if you're missing stuff. So like right here, I'm thinking, oh, what if the variable isn't divisible by 3 for this? What do we do? Well, they should be entering 3, 6, 9. What if they enter 7? What do we want to do there? And so that's got me thinking, maybe I need to read in the size variable until they enter a multiple of 3. So like check if multiple of 3, if not, read again. So maybe I need to put some sort of loop in there. So it's got, the idea of the pseudocode is just to let you quickly kind of go over your algorithm and see if you can get it clear in your mind. Some things to keep track of, like I think it's nice to put in the data types, sizes, and strings or ints or stuff like that for that. So again, you can decide how Java-like or how English-like you want to write this here for that. So again, you're supposed to provide the pseudocode. And again, you don't have to do all of your steps or methods, but some of the key parts of it. So like what I would suggest often here, we're going to take our problem, divide it up into a group of methods we might be calling. For like in Pokemon here, I could see a method for adding a Pokemon, a method for deleting a Pokemon. Here, maybe a method for initializing the Pokemon or printing out the Pokemon list. And then again, write some pseudocode for a couple of those methods, like 2 or 3. So, for the implementation plan, how would you build this here? Beginning users often start the beginning and build the whole program kind of from the start here. But when you have more complex programs, sometimes it's better to jump in and say, well, can I even do this? How would this work? And so sometimes I suggest users skip over the input and not get too confused on the input and just initialize a variable to some value and then see if you can print that out. So maybe if you have, sometimes you'll see me doing that in class, rather than inputting things, I'll initialize, just add a couple values to, I'll just add 3 Pokemon names to a list. And then once I have that, try to do some things to that. Can I print off that list or something like that here? So your implementation, you can just say, well, I do step 1, step 2, so, I do in order, but you might want to think, what are some of the more complicated or stuff that isn't so critical, do those later and do some of the critical stuff. I think the stuff related to data and how your data is going to be organized is helpful here. And again, the other thing would be break some of these more complicated things up into parts for this here. I'll let you work on that a little bit more, and then we'll talk about coding this. Now, you don't have to write any code for this, but I think it's helpful to try, as you're learning this, to try to write some code to see if your pseudocode maps into real code as you're learning to do this. So, question?
You have to write pseudocode for the whole thing.
No, you have to write pseudocode for a couple of the key steps or methods.
Okay.
Okay. So you just have to write the pseudocode and break the problem up. You don't have to write any real code for this, but I actually think, I mean, it is useful to write code for this as you're practicing this sort of stuff. So again, you don't have to, but and again, you can do this when in future assignments that you work on an assignment, try to break it down and write some maybe pseudocode and then see if you write code, how it will work there. So here's an example of this. So we want to print off these, like this top row. So I'm going to write that. So I wrote some pseudocode for that. Now the top row, for example, if this is 9, we broke that down and said that's really just a 3 because it's 9 all the way across. But if we divide by 3, that's a 3. So we want to, because we want to print out 3 stars, I mean 3 spaces, and then 3 stars. If it's 2, we want to put 2 spaces and then 2 stars. So that's basically what I want to do is the number that many spaces, that many stars. So our pseudocode is like that here. We're going to loop through, and he has a variable called a third size. That's that 2 or 3. And we're going to print off that many spaces, and then we're going to print off that many stars. So again, I would maybe just put this in my code here and try it out. Sometimes I just paste my pseudocode if I have actual pseudocode and put it in here and then convert it to actual code. So loop through the third of the sizes. So you can just say, the idea is that once you do this, you can just convert this into code for int maybe space equals 0 space less than third size space plus plus. And then I'm just printing out system dot out dot print line, or just print, not print line, and then I'm printing out space. So again, I basically just converted this into that code. And again, that's the idea of writing pseudocode is you don't have to worry about all these details. You can just write it quickly for this. Same here, I want to print off the stars. I'm actually going to just copy this and duplicate it down here. And print out the stars. And then I'm going to do a print line. Now, like I was saying earlier, I can test this out without having to do all the initial input. I'm just setting my size to 3, and I'm going to call this method for this. And then see if it'll print off. So it looks like it's printing off the right number of stars and then some spaces. And then so it looks like at the beginning and end of that. Again, I think it's helpful sometimes to try to take your pseudocode and do it. It helps because, like, to clarify things, the next thing is to print off these middle rows here. And I was going to make a method just to print off one middle row and do that. That's what I would have written here. Print middle row here. But when Chris was designing this, he was thinking of printing off all the middle rows. So you have a loop within a loop for this here. Uh, and so again, you can decide which way you want to do it. And sometimes, again, if you actually try it out, it will force you to loop through that here. So again, you don't have to write any code for this, but you're welcome to. How about using AI for this? So the goal, I mean, you can certainly use AI for all of this. It will do an okay job for this. But again, it's the goal of this is for you to learn how to break a problem up into steps, not for you to learn how to use AI to do that. So I would suggest if you're going to want to use AI, you should try to do it yourself and then have AI check your answer or refine it for this. Some things I will warn you. So I took this Pokemon example here and put that into ChatGPT, pasted all in here, what I needed. And it came up with this overall plan. Here's the decomposition, and I thought this was relatively good, but AI tends to make things more complicated than we need to. So it added some more complicated steps like a search for Pokemon by name. That was never, there's no mention of searching here. I mean, if you're going to do a program like this, you may want that, but that's not within our scope. So, and again, sometimes it'll tell you list all the Pokemon. I think this is optional, but is helpful here. It's not a bad decomposition, but again, it tends to add features we don't need to for this. So, as far as when we get into the code it's going to create is more complicated than what we can have, what we know how to do. One of the things that AI has is we don't know how to create what are called objects or classes yet. And for something like this, you're going to want the most obvious way, if you knew how to use classes, is to use a Pokemon class for this and then create an array list of Pokemon objects. But we don't know how to do it. So again, you can, it generates some pseudocode here, but I went back and say, okay, I don't know how to do classes yet. We are covering objects and classes in a future lesson. We won't get to that till Java 2, actually. How can I do this without a Pokemon class? And again, so then it broke it down into separate array lists for this. So again, if you are using AI to help you, I would say don't use AI from the start. Try to do it yourself and use it for some feedback and watch. Make sure it's not suggesting stuff that we don't know how to do yet. And the main thing is objects or classes. And then also watch for it adding additional features or things that we don't need. It likes to do error checking. We have to do minimal error checking in this. The requirements don't have much error checking in it, so it likes to do that also. Okay, so I'm going to go talk about this sort of algorithmic thinking stuff when we're doing this. So we're doing problem decomposition. Another thing to watch for is pattern recognition. What patterns do you see in here? And again, things like printing out all the elements in the array. In the Pokemon thing, you're thinking, well, one thing I'll probably want to do is if I have an array list of Pokemon is to print out all their names or stuff like that. So again, I should recognize that pattern. How to add something to a Pokemon. So again, you can think to programs where you've added something to, and again, so that might inform you that maybe I should be using an array list instead of an array here because I know how to add items to an array list. I don't know how to add items to an array. So abstraction, what are the important details of this problem that you're trying to do? And again, eliminates the unnecessary thing. That's why I often tell students maybe to skip over some of the user interface things right away, how you're going to loop or how you're going to print out, what are you going to call this, and just focus on, maybe what is the data, how are you storing that, how are you displaying that stuff. So, and again, when you're doing pseudocode, hopefully that forces you in this algorithm design. So, what are the step-by-step processes? So how do I print off an array? How do I add, what are the details to add a Pokemon or to do something like this? So now we do a lot of pseudocode here. I actually like to draw out charts or diagrams of this. I'm much more of a diagram person. So when I'm doing code, I often are writing methods and putting circles around them and having pointers, going around and saying, well, we're going to do this and do this. So although you're going to do pseudocode here, you can decide when you're writing it. I often just like to take a piece of paper and quickly lay out what the program looks like on a piece of paper. And I have, a method of my main method. I'll have an arrow going over to this method and coming back, an arrow going to another method going back, and lay it out that way. So there are different charts. And again, there's not one chart that works better than the other or whatever. There are lots of, some of them are called flow charts. There's a whole area of UML called UML diagrams. I use some standard ways of doing that. It is useful if you're a company to kind of use a standard layout that the company owns so that other people understand what you're doing if it's something you're going to share with others. So. But again, this iterative refinement, and that's why I sometimes find it useful to actually start looking through or writing some code and then going back and refining it and saying, oh, we really need to check if the user enters a multiple of 3, or we need to break this up this way or that way. So, okay, so for this assignment, again, you just have to post a program plan with steps and pseudocode for a couple key steps or methods. So like maybe 2 or 3 key methods, an implementation plan, what order you do it, and then find at least one of your complicated steps and see if you can break it into at least 2 parts for that. So one of your methods or one part of it, see if you can break it into smaller steps for this. Okay, post this. And those of you in class, maybe you can post it already, and then you can go and reply to other people's posts today. So post an alternative list of steps or methods for one of the other students. So find their part 1 list of steps and say, that's a good one, but maybe you could break it up this way instead and, do some tweak to it. Like I was saying with Chris, the way he broke it up, I would, again, I think mine are relatively subtle. These are relatively subtle things, but I would put the user input in the main method. I would also, he prints out all the middle rows in one method. I would break that into smaller steps where you print off 1 row and you call that multiple times. Gesundheit. Okay. So again, that would be an example of something we can do. So your job today is to post something to the discussion and then reply to someone's post with some alternative steps. Got it.